Hey, Ainsley Colombo here, and I'm going to teach you how to take the implicit differentiation of an equation. Now, I'm doing problem number 7 from page 171 in the textbook. Now, the directions for this equation simply state, take dy over dx by implicit differentiation. Before actually getting into the details of solving this equation, you need to know a few things about taking the derivative and other rules that apply to it. So I'm going to teach you. First, I'm going to start with the derivative. Now, up until this point in the textbook, you have seen equations that simply look like y equals 3x to the second minus 5. Now, this is only an example. Usually when seeing this, students will simply take the derivative. But notice, this says y equals, and this equation says equals 0, and the y is inside of the equation. That is because this is the explicit form, and this is the implicit form. Now, usually when looking at this equation, a calculus student would simply just take the derivative. And if you don't know how to take the derivative, I'm going to teach you right now. So you're going to write d over dx, which that's stating that you're taking the derivative of this equation. So it equals, okay, so the first term in this equation is 3x to the second. Now when you're taking the derivative of a term, you want to look at the exponent and you want to multiply it by the coefficient. So 2 times 3 is 6. Once you do that, you want to take the exponent and subtract 1. So minus 1 would be to the first power, so 6x. Now you could write that 1 right there, but it's pretty much implied that it is to the first power. Now, the second term in this binomial is negative 5. Negative 5 is a constant, and when you take the derivative of a constant, it's simply just 0. You can also write plus 0, but once again, it is implied. Now, if you want another example of the explicit form versus the implicit, something as simple as this would be y equals 1 over x. This would be the explicit. And then if you want the implicit form, it would be x times y equals 1. That's the implicit. Now, so that is how you take the derivative of an equation. If you still don't know how to do it, you can simply pause this video and go back, but I'm going to erase this. So, now the next thing you need to know so that you can solve this equation is the product rule. Now the product rule simply states that you take the first term and you multiply it by the derivative of the second term, and then you add the second term and you multiply it by the derivative of the first term. Now, an example of this would be 3x to the second multiplied by 4x to the third, for example. Now, so you're going to take the first term, 3x to the second, and then you want to multiply it by the derivative of the second term. Now, taking the derivative of 4x to the third, you take the exponent, multiply it by the coefficient, that equals 12, and then you subtract that 1 from the exponent, so it equals x squared. So you just add it onto there, and then you put the addition sign to add the second part of the product rule. So you want to write the second term. So the second term is 4x to the third. Now, you take the derivative of the first term. So you have that 2 times 3, which is 6, and then you write the x, you subtract that 1 from the exponent, that gives you 1, so it's 6x. Now, that is how you take the product rule. Now I'm going to erase this. Obviously, you can pause it and go back. However, I'm going to erase this. So, now that you know a few rules, you can now take the implicit differentiation of this equation. Now, the first term in this trinomial is x times e to the y. Now, since it's multiplying x and e to the y, you have to take the product rule. So we simply write the first term, which is x, multiply it by the derivative of e to the y. E to the y is an exponential. So when you're taking the derivative of an exponential, for example, say you have e to the x. Now e to the x, the derivative is d over dx equals e to the x. As you can see, the derivative of an exponential is itself. So now if you're taking the derivative of e to the y, you're going to write e to the y. So let's put that little y there. And you notice there is a y in this part of the equation. Now, when you have a y and you're taking the implicit differentiation, you have to put a y prime next to whatever term that you're taking the derivative of. So you have that y prime, you put the y prime right there. Some people write dy over dx. I like to write y prime. They mean the same exact thing. It's just my preference. Now, you're going to take the second part of the product rule. So you're going to put that addition sign, and you are going to take the second term, which is e to the y, and multiply it by the derivative of the first. Now notice that the derivative of the first term, this is simply an x. So all you have to do is subtract that 1 from the exponent. So 1 minus 1, that gives you e to the 0, which equals 1. So you multiply it by a 1. So the derivative of x is simply 1. Now, the second term in this trinomial is negative 10x. And all you have to do for negative 10x is simply just take the derivative. So negative 10, because you have that 1 there, you multiply it by negative 10, and then you have 1 minus 1, which is x to the 0 exponent, and that's simply, again, just 1. Now, the third part in this trinomial is 3y. 3y is similar to negative 10x. All you have to do is write positive 3, and then you have 1 minus 1, that's y to the 0 power, which equals 1. But notice there is a y in this term. So what you have to do is you write y prime. Now, what you're going to do is finish it off, which equals 0. So you pretty much just took the derivative of this equation, but you're not done yet. What you have to do next is you have to get the like terms and put them on one side of the equation, and the other like terms and put it on the other side of the equation. So I'm going to put in equality sign here, equals, and then I'm going to get all the y primes on this side. So we have x e to the y, and then you have the y prime plus 3y prime. Then on the other side, so let's just cross these out to make sure that we don't get it mixed up. On the other side of the equation, you're going to have, okay, so we have 10, negative 10. You add it to this side, it becomes positive 10. Then you subtract that e to the y, that becomes negative e to the y. Okay, now you have that part. The next thing you're going to do is you're going to divide those y primes out, because the goal of this equation is to get the y primes to equal the equation so that you can get it in the explicit form. So here we go. We're going to take the y prime out, and you're going to put the parenthesis x e to the y plus 3, finish off that equation. 10 minus e to the y. Now, when you have the y primes multiplied by this term, you want to divide this out so that you get the y prime by itself. So here you go, multiply the x, or divide the x, e to the y plus 3, x e to the y plus 3. Cross that out, then you have y prime equals 10 minus e to the y over x e to the y plus 3. So there you have the differentiation of an implicit equation. Your goal was to get the y primes to equal the equation. That looks like it's all done, and it's pretty much just finished.